Protein is critical for many reasons. As you well recognize, the purposes of protein in terms of all of the many functions in the body. But in terms of athletes, we're looking at the small amount of contribution that protein will have for muscle energy. The muscle can utilize or oxidize amino acids, and the three that are highlighted are the branched chain amino acids. These are especially important because they can be metabolized without being broken down in the liver or deaminated. The myofibrillar turnover continuously is occurring, and so we need to have an available pool or utilization of a pool of amino acids for protein growth and development, as well as the components of hemoglobin, hormones, enzymes, and immune cells. Now what you see in the figure here is what's referred to as the Cori cycle or the lactic acid cycle and the glucose alanine shuttle. The Cori cycle is the way during exercise that lactate is removed. It shuttles to the liver, it goes through the bloodstream to the liver where it can be converted to glucose and then returned back to the muscle for energy. But the glucose alanine shuttle is what ties in the protein component, because this just shows how alanine, which is one of the important amino acids used for energy, can be released from the muscle, converted to the glucose, and then returned back to the muscle. And here you have alanine converted to pyruvate that produces urea. And so that movement of that nitrogen ion or that NH3 molecule that allows the production of glucose, which ultimately gets utilized for maintaining blood glucose and potentially available for exercise glucose energy source. Now, protein can play a role for exercise metabolism if exercise is prolonged, and that is several hours past a couple hours of exercise. Then you see that amino acids or proteins can participate in up to 18% of fuel contribution. This is the connection of amino acids to glucose metabolism or anaerobic metabolism. TCA is a tricarboxylic acid or citric acid cycle, and here you have pyruvate in the blue box, which is the end of glycolysis, which is ultimately converted to a molecule which is named acetyl-CoA. Acetyl-CoA is then able to fit in to the tricarboxylic acid cycle. And where you see the yellow squares, those are places where skeletons of the or part of that amino acid can be stripped of the nitrogen and converted into one of the TCA intermediates. So that's how protein fits in to the aerobic metabolism. These are the branched chain amino acids. These are the three essential amino acids that are broken down in the skeletal muscle, and these can be these are important because those are the ones that can be oxidized during exercise, and they're right in the muscle. So that's one of the reasons why the branched chain amino acids are focused on for potential supplementation. The primary concern prior to a competition is really a full tank of glycogen, because remember, carbohydrates are the primary fuel for metabolism, but you also need to have sufficient calories, and that's one of the key components. So up to a day, 4 hours to a day before exercise, we're going to be sure that we follow the low fiber, more carbohydrate predominant foods that are familiar for that athlete. Now the authors give you a meal idea for pre-competition, and what you'll see is that these foods are, whether it's breakfast, lunch, or later in the day, you're looking at lower fat sources, leaner protein sources, and sources of carbohydrate as being your good foods to top off your glycogen stores. Now here's where I'm going to just point out quickly that the recommended allowance is going to be slightly different for the athletes depending on what their athletic endeavor is. So a recommended amount is RDA is 0.8, which is about 0.4 grams per pound. And if we want to put that to a reference individual, a 160-pound individual, that would be 58 grams. But this is the minimum amount. It's not necessarily the optimal amount. Now, exercise is going to increase the demand, and all I really want you to know is, or to recognize, is that the range is greater for athletes, and what might be surprising to you is that we have a little bit lower. Here I said that the real high one is 2 grams. This is looking at if we get 2 grams per kg, we're hitting the mark quite well. So how should we eat our protein? So how does the story go? Well, the old theory stated that there was an anabolic window, which is really 30 to 60 minutes following resistance exercise, when our muscles are really at the most viable and the most accepting to amino acids and growing skeletal muscle. The thought was that if you fail to eat some protein during that 30 to 60 minutes, that you're not going to be able to build muscle. So that eating that protein, gotta have it right away. But sometimes athletes, when they exercise intensely, they're not very hungry, so it makes it a challenge. If it's greater than 60 minutes, well, we're not going to get as good of muscle growth. Is that really the case? This particular study indicates what happens if you compare the myofibrillar fractional synthetic rate, which is basically muscle building, myofibril building. What is the rate if you're fed at rest and if you're fed, comparison, 24 hours later? So we have three different levels of exercise done by some young men. So they did 90% of their 1 RM to failure. Then they did another time they did 30% of the 1 RM to the same level of work. So they completed the same amount of energy expenditure. Or they did 30% of the 1 RM to failure. So they did many more repetitions, but the load was much lower. So this is the rate of that FSR, or myofibrillar building rate at rest. And this is 24 hours after that exercise. So you'll see in that first and last exercise session, when they went to failure, that their myofibrillar rate of growth was elevated for 24 hours. However, if they didn't do exercise to failure, that it wasn't elevated for 24 hours. So what we see is that when you do that exercise at that high intensity, that your need to eat within the first 30 minutes is extinguished. What about branched chain amino acids? Well, we do know that protein can serve as an energy source if the exercise is high intensity and for a long period of time, although it's a very small contributor. But we're not finding a lot of evidence that it's helpful during exercise. Now, there is some research that indicates that branched chain amino acids can be helpful during competition. That's because those are the only amino acids that can be metabolized for energy in the muscle itself instead of needing to be processed by the liver. But I'm not 100% convinced that that's going to make a big difference. After competition, about 20 grams of protein is a good rule of thumb post-exercise. And if you can get something with leucine, that's really great because that's one of those essential amino acids. And here I'm going to push back a little bit with what the author says, at least 2 to 3 hours after competition. I'm going to suggest that the most important thing is to have that consistent, good dose throughout the day. Encourage a greater consumption in the morning and also getting some before bed. So we have this daily fluctuation, but we tend to miss or ignore the period of sleep where we have this prolonged period where we are voluntarily fasting and we're not exercising. And so the thing to consider is if you take some protein before bed, can that be beneficial? So Russ Groen-Pennings and their lab looked at this pre-sleep. Can you do something to avoid that breakdown and delay it somewhat with taking a dose of protein before bed? And we know that casein tends to release the amino acids a little bit slower than whey. Casein protein is still rich in leucine, which is one of the key components to the myofibrillar protein synthesis. And so it's a little bit more delayed, and so it's a nice option. But we do have evidence that consuming 30 to 40 grams of casein protein before bed can actually have better offset that negative protein balance. And here we see what happens, that protein leucine concentration, the difference is casein is much higher, and whey you have that big dip. And so casein protein before bed might be a better option than whey protein, where in some cases we look at whey as being the best choice. So some things to consider about protein metabolism. See you around the next one.